Great. Hi, everybody. I'm Dr. Nick. Wait, no, that's something else. Fun fact, I was the medic for a roller derby league, and my derby name was Dr. Nick. Hello, I'm Nick, KN6NK. I have been licensed since 1999. Currently an extra class. I came down to Cal Poly in 1998 to join the Ham Club. My first meeting here was a bunch of people throwing Monty Python quotes around and tormenting each other with laser pointers, and I realized I'm wrong. So, yeah, glad to see the club is still around. And we're all finding our people. So yeah, I've been doing radio stuff for a while. By day, I am a security engineer at Amazon. Don't ask me anything about Amazon because they'll yell at me for having mentioned that I work at Amazon. So, this is about a listening post that I set up. My parents live in Templeton in an RF quiet area, and then I decided to kind of take advantage of that. So, come on. Wrong button. There we go. Okay, so I like to track aircraft. It's fun. So I set up this little box with a Raspberry Pi and a couple of SDR receivers at my parents' house, and it worked okay. These little 5 dBi antennas sitting inside performed decently enough. But I thought I would like to do something a little more interesting. I'd like this to perform better. I'd like to maybe listen to a few more things. Let me describe what ADS-B is first really quick. So with air traffic control, you have primary surveillance radar and you have secondary surveillance radar. Primary surveillance radar is just the, what you think of as radar. You send out a signal, wait for the echo reply or the echo to come back, and you know, okay, based on how long that took, there's the thing this far away. It doesn't give you any information about what the aircraft is, where it's going, anything like that. Secondary surveillance radar sends out an interrogation pulse, and there's a transponder on the aircraft that will respond with its squawk ID, its ID code, altitude, and a few other things. And so the secondary surveillance radar will say, okay, when I pinged it, I was pointing this direction and it took this long for a reply to come back, so I know it's this far away in this direction, and there are these additional parameters. That's great for ground or air traffic control, because now they know where stuff is. It is not useful to any other aircraft in the area, and so that is where ADS-B came in. It is automated dependent surveillance broadcast. It's basically APR's position reports for aircraft spammed multiple times a second. And so if you set up a station, you can hear aircraft sending these out and see where they all are. And it looks like this. This is the current sky over Templeton, centered on that little dot. Anyway. So I thought, okay, I want to do something a little bit nicer than this. So I'll put it outdoors, give it a better antenna, maybe add a couple things, or 12, and I hit just a massive case of feature creep. So this is all the stuff that I'm running in there. So ADS-B and UAT, which is UAT being the general aviation version of ADS-B, it's in the US only. ACARS and VHF data link are both data telemetry protocols used by aircraft. Things like, you'll see messages like, oh, our toilet is broken, or the seatbelt in 24F is sticky. It's also used for filing flight plans, things like that. Radiosondes, so as the National Weather Service sends up weather balloons, you get to see where all of those have been. So if you ever feel like chasing weather balloons, it's a lot of fun. HF data link is like VHF data link, just on HF for transoceanic flights and the like. in a Kiwi SDR, which is a little BeagleBone Black plugged into an FPGA that samples all of the HF spectrum and then spits it out into 8 digital down converter instances in the FPGA so you can view them through a web SDR interface. The Kiwi SDR also let me do whisper spots automatically. I have an Iridium antenna to listen to ACARS over Iridium, which is in the clear, which is fun. Iridium being a constellation of low Earth orbit satellites. It's kind of the OG satellite phone network. GOES-17 is one of the National Weather Service's geostationary weather satellites. So I can pull images off of that, and that looks like, let's go with this. Takes a minute because the cards are on a cable modem and the upstream bandwidth is bad. So yeah, I can see all of the live images from the weather satellite as they are beamed down, which is just kind of nifty, I think. And it came back for some reason. All right. Yeah. I have a radiation detector because why not? It gives counts per minute through a little just JSON endpoint that it runs. And this is all sitting on the Arden mesh as well. I have an RF link to TAS, and it is also connected to one of the telnet ends. So, there are some things that I want to add to this, as if I wasn't doing enough stuff before. There's a network called the Global Meteor Network, where people have cameras pointed at the sky and they look for fireballs. With enough cameras pointed at the sky in different places, you can tell where they entered the atmosphere and where they came down. BirdNet is a service that you plug in a microphone and it listens to bird songs. And it will track basically migratory patterns of birds and bird populations, which is really cool. I want to put up an N-Tripcaster for RTK, which is a way of, you set up a GPS antenna, it knows exactly where it is. You do a survey in, say I am right here, and it sends its corrections data for the signals that it gets from the GPS satellites that say, okay, so I am here. There's some weird ionosphere condition that causes a weird phase delay in some of the signals coming from GPS satellites that make it seem like I'm here, but I know I'm here. So I'm going to generate correction data for that and then make it available to others that have a receiver within, it's effective within like 30 kilometers, I think, that will let you get centimeter level precision with your receiver. It's really useful for surveying, for drone stuff, lots of fun. If I have the budget for it, I will throw in a geophone system that will listen for earthquakes effectively. And I was going to put up some SatNOGs antennas, but I'm going to put those at my house instead, because I ran out of antenna ports on this thing. Yes?
Do you have plans to do any kind of POC site monitoring?
Why would you ask me about POC?
Is there any POC site traffic in the area?
Oh my God, there's, yeah. I used to work for a Better Beep, which was our local paging company back in 2004. I can still hear POC in my sleep sometimes. And I am working on setting up a POC transmitter for a hacker conference, or a hacker camp called TwerkCamp. Where there's a group called ShadyTel that runs literal copper wire all over the island where the camp is. They have a phone switch set up, and I'd like to interface with that so that people can send pages, because this is the sort of thing that hackers do. do not have plans to monitor POXNet. I will probably start listening to like public safety radio or something before I do that.
What is your website?
Post office group pagers. One-way pager traffic. When you see like somebody in a hospital show and they have a little thing on their waist that starts beeping and they go, "Oh, I'm blah blah blah." That's a pager, and it's probably POXAG that is being transmitted to for that to pick up. Either that or Flex are the two major protocols.
Do people like still use pagers a lot? Or like,
Yes.
Oh, yeah.
Hospitals use them a lot. They have in-house paging transmitters. Process automation and industrial facilities use them a lot to send alarms when things are going awry, if there are sensors reading out of limits, things like that. Yeah, it's still used.
Why do they like choose to use it just like that?
It's easy. It's very easy to set up a transmitter, VHF or UHF, and just, yeah, you don't have to have anything complex. So, yeah. I'm going to go through just kind of the hardware that I put together, and then the software stack, and then I'm going to go through a ridiculous number of pictures that I took of everything so you can kind of see what it all actually looks like put together. So grounding is important when you have antennas out in a field somewhere. So I've got a gas discharge tube, surge suppressors attached to all the coax, as well as all the unshielded twisted pair for network stuff. It's connected to a single ground bus inside the box that this is mounted in, and that in turn is bonded to the tower, which is then grounded through the mounting posts that are embedded in concrete deep into the ground. The tower is just a 10-foot top section of Roan 45G, which used to belong to the club, which was given to the club by Cal Poly Public Safety when they disassembled their tower. Power comes in as mains AC. It goes through a surge suppressor and an AC noise choke. This is on the same circuit as a well pump. So as the motor kicks on and off, I thought maybe some noise suppression would be a good idea. It then goes to 3 different DC PSUs that provide output for the various things in the box. Each of those goes to a separate fuse block that has fuses, because if something goes bad, you don't want it blowing up. Fuse blocks are fun. They have an LED parallel to the fuse, so that if the fuse blows, all the current for the device tries to go through the LED instead and lights it up, but there's a current limiting resistor, so it can't actually power all of your stuff through the LED, however brief that would actually work. So you can tell which fuse is blowing. I've got some DC noise chokes that I also added for anything that is actually doing RF stuff, just to kind of keep any of the switching power supply ripple out. And I've got some PoE injectors for the network gear. Speaking of the network, this should look familiar if you've played with ARC and stuff. It's all MikroTik gear. I have the HTTP AC light as kind of the core, a Lighthead Grid 5 as the link to TAS, and then the SXT-SQ is the one of the little patch things, and that provides the internet uplink that it has through my parents' house, and just a generic 100 meg switch. For compute, I used to have a CompuLab Fitlet 2, which is this cute little industrial box. It had an Intel J3455 processor, low power. It used to be a pretty nifty efficient processor compared to a Pi 4, about 3 times as fast. And then the Pi 5 came out, and I said, I can't have that. So also the weather satellite stuff takes a lot of horsepower from processor. So I switched out to a machine with an i3 N305. Intel's new efficiency cores are really, really cool, and this series of processor has just efficiency cores in them. They're single thread, but it has 8 cores in it, so that works nicely. And it's still only 15 watts. It's not like I'm really power constrained in this box. USB is simple. I've just got a couple of USB 3 hubs. I went with USB 3 hubs because they do not have a single shared. So if you use a USB 2 hub, all the devices you have plugged in share that USB 2 bandwidth. A USB 3 hub is a bit more like a switch, network switch. So each of those USB 2 devices gets its own dedicated, like 400 megabits per second of throughput. So with all of the SDRs in there, I thought that would be good. And speaking of the SDRs, I have 6 regular RTL SDR dongles that have the Realtek tuners. I have one that has an E4000 tuner in it. The difference is the E4000 tuner is still able to lock at higher frequencies, like around 1.7 gigahertz, around the frequency that the GOES satellite downlink is, whereas the Realtek ones, they're a little less stable around it. They don't always lock, and so they don't really work for stuff right at the edge of its tuning range. I did replace the QB SDR with 2 Web 888s. It's basically the same thing. They have a Zinc processor on them instead of having a separate FPGA in BeagleBone Black. It's got a little bit more processor horsepower, a little bit more FPGA space. These have up to 12 DDC slices in them, I think. So you actually get more tuners in them, and with 2 of them, obviously twice as many more tuners. So yay. A couple of AirSpy HF discoveries and an AirSpy R2.
Question.
Yes.
How much do the 888s cost?
Don't ask me how much I think they were about $220 each.
Not bad.
Yeah, they're less than the QB SDRs. And also, unlike the QB SDR, they have an actual separate hardware GNSS receiver, whereas the QB SDR does that in the FPGA. RF path is fun. I've got a bunch of antennas. They go through a bunch of different things. Multi-couplers are your friend when you're doing stuff like this. It is a power divider / isolator that also includes a low noise amplifier to effectively overcome the loss you see from the power dividers. So it kind of gives you a unity gain output on multiple ports. The ones that I have are about $200 each. If you want to do this cheap, go and get a cable TV drop amp. They're like $40. Look for ones that are unity gain or 0 dB gain, and they'll do exactly the same thing. It doesn't matter that it's 75 ohms instead of 50. When you're doing just receive, it works just fine. I went this way because I could. Yep.
Do you have issues with like strong signals overloading the HF to HF stuff?
Not here, no. I put it in this area because there's not a lot of local RF. Although now that the Templeton Public Safety Center is opening up, that may change. But I don't think it's going to cause a problem. It's far enough away and it's not high enough power. Down in AG, I know there's an AM broadcast station. Mark Smith N6NK has had to develop an AM band stop filter, just so that he can actually like test his own stuff down there. But yeah, I have had problems with H-70, the CHP aircraft, or helicopter. When it gets close enough, it will overwhelm the LNA that I have in front of the ADS-B receiver. And so it will basically drop out. It just overloads it entirely.
That's on the helicopter ADS-B translator or
Yep.
What's an ADS-B translator?
automatic?
The aircraft position transmitter stuff. So yeah, that one, and it's if it gets really close, like within, I don't know, half or quarter mile and within a couple thousand feet altitude, it takes a lot. I did put an 850-ish megahertz high pass filter in front of that, and that kind of rolls off any local cellular stuff.
Where do you implement the high-pass filter?
I built it, just, it's an LC filter, and I used the SVC filter calculator. It's the standard value component filter calculator. Most filter calcs will tell you, oh, you use an inductor of, 1.03857 nanohenries. I can't find it on DigiKey. So the SVC filter generator will actually take just like a table of generic decade component values and say, okay, you want to use this component here, this component here, this component here, and you actually go order those and put them on a board and they work.
Did you, this the board in this case, is it like a PCB?
Yep.
You design it on?
This one I found in Park. It just had pads for like 0805 size components.
Started them on?
Yeah.
Awesome. Nice.
I also threw an anti-parallel diode on the input to help dissipate static before it hit the LNA. So it's kind of the RF path, just a bunch of stuff shoved through. Software stack, I bit the Docker bullet and deployed an image that has all of the aircraft position tracking stuff. All the others I just grabbed from GitHub, compiled, and set up systemd unit files to run. I can give links to all of these as well. I'll give you a copy of the slide deck once I've put links in, and then everyone can enjoy. As far as what's next, this thing was ridiculous. I'd like to make something a little less ridiculous that I can still deploy in several places. So I've got a few people that are interested in hosting a smaller monitoring box. I just need to figure out exactly what that is going to look like. So let me then really quick show you some pictures. Where's this was just me laying out kind of where everything was going to be. I decided to go with DIN rail because it looked neat.
How did you attach the microchip stuff to the DIN rail?
With stuff like these. So there are little DIN rail clips that you can get, and then I just screwed them onto the microtik gear and the QBSDR, the network, the computer, and turned them into DIN mount devices. These things are really cool. These are rivet nuts. It's a rivet that is threaded. So if you need a threaded hole somewhere in a thin piece of sheet metal, you can just drill a hole, shove this in, and then you have a threaded mounting point. I highly recommend them if you have to mount anything threaded to sheet metal. This is what one of the multi-couplers looks like inside. some of the surge suppressors. Here's the power setup. So I've got AC coming in, goes through a breaker, surge suppressor, noise filter, and then the DC power supplies. Let me find a more interesting photo. Oh yeah, and the box that they're in is kind of, it's a 24 by 24 by 10 inch deep, just steel cabinet. And then all together, all assembled, this is what the antennas look like. This is what it looked like as I was putting it together. So it's kind of ridiculous.
So, what did he end up making?
Oh, like what was the goal?
Just to kind of watch aircraft pull down data, and just listen to stuff. Just enjoy aircraft information and grabbing data out of the air and seeing what all is there. Yep.
If you said you wanted to make smaller boxes and reduce the complications. So how would you split, say, this into a few different packages?
I do less stuff. So if I can pare it down to just the like ADSB and the ACARS and VHF data link stuff, I can do it a lot more easily in a small box with like 4 to 6 SDRs and just a couple antennas.
How is temperature and moisture control in this box?
I've got vents on the sides up at the top and a fan, an intake fan down at the bottom that is controlled by a thermostat. Once it hits about, I think 85 or 90 Fahrenheit, the fan kicks on. And then when it drops like 3 or 4 degrees below that set point, it turns off again. This being Templeton, it does get hot. It has never gotten too hot for stuff to operate. And moisture buildup just hasn't been a problem. I've had no issues with it, and no bugs have made homes in it.
So there's just dust filters on the exhausts?
Yep, and on the fan on the bottom
Okay,
too.
yeah.
Can we please talk about the power supplies?
Yep.
What they are?
They are also DIN rail. These are just Meanwell AC to DC switching power supplies that are DIN rail mount. So yeah, the AC power goes in the top. DC comes out at the bottom. Technically the other way around. I flip them around, but they work either right side up or upside down. The manual said that that was fine.
Did you use like a label maker?
Yep. Just so I knew exactly which one was which. I did that on the DC blocks as well. Not DC blocks, the fuse blocks as well. You can kind of see one of the labels down there. Yeah.
Awesome.
You had another
Me
question?
first, do you do any kind of voltage and current monitoring on the power rails?
No. Yeah, I don't have any stuff like that in there.
Oh, ADSB is the stuff that Flight Radar uses, no?
Yep.
Yeah.
So I feed to a whole lot of different sites, several free ones, as well as Flight Radar, FlightAware, and Plane Finder, I think.
Cool.
And if you feed to the commercial sites, usually they give you a free enterprise account. So there's a reason to grab an SDR and plug it into a Pi on your desk or something.
Life hack.
Yeah.
What do you mean?
So the transmissions from the aircraft go out and say, I am here, this is my altitude, this is my speed, my direction. The receiver receives that, collects that information, and then sends that over the internet to these various aggregator sites. So, like one of them, ADSB.fi, receives this data from feeders all over the world and plots it so that, you know, your receiver can see aircraft within, I don't know, 100 miles or whatever, but it can't see stuff in New York. Somebody in New York, they can't see stuff in Saskatchewan. So everybody feeds their data together to these aggregators, and then they all get the benefit of, you know, being able to see all of the aircraft, all of the places.
So ADSB didn't have any information in that area?
There was some coverage. What I actually did fill in was the UAT stuff, so the general aviation stuff. Not many people have put up 978 megahertz receivers in addition to the 1090 megahertz ones. Also, the more receiver stations you have for aircraft that don't have the beaconing set up, if they have an older transponder only system, it's called Mode S. You know, the secondary surveillance radar will make its interrogation. The aircraft will transmit out its data in response, but it doesn't have a position in that data. It has altitude, and the secondary surveillance radar, since it knows where it was pointing and when it transmitted its signal, and when it received that response, it knows what direction and distance that aircraft is. But nobody else does around. So the more stations you have set up that hear that response, they can, based on the time of arrival of that signal, figure out exactly where it is between them. So it's called multilateration. And so with more stations, you have greater precision for multilaterating transponder signals. Yes?
Thought I saw something about a Kraken finder dish.
Oh, it's not a finder, it's the, it is just their discovery dish.
Discovery, that was the word.
And it is just a nice, yeah, it's like a 2.5 foot diameter dish. I was using a grid antenna, which you can see up here. The problem is this grid's mounting points only give it offset axes of 0 degrees, 45 degrees, and 90 degrees. And based on where I am and the satellite was, I needed to have it offset 22.5 degrees. Because for some reason that satellite transmits a linearly polarized signal. So, yeah, so that's basically it. As far as kind of the what's next thing, I got one of these boxes off eBay and threw a couple antennas on it. And I'm trying to figure out how to couple a single board computer to the case inside to actually use this as a heatsink. So that's kind of my next fun little thing.
What is it?
It is a thing that sinks heat. So your processor in your computer or on a Raspberry Pi or whatever generates heat as it operates. You will put something on it that is very thermally conductive, like aluminum or copper. It has a lot of surface area to transfer that heat to any air that goes past. So with this is an aluminum box, and the back is fully finned, so that gives you some nice surface area to dissipate heat into the surrounding air.
So this would be a heatsink for the entire system.
For at least the processor and probably the SDRs as well. The SDRs get a little toasty. Yeah, this thing is kind of waterproof, weatherproof, so it can be mounted outside.
How come like rain doesn't make this? Or can you just like drop it in the water?
So with the box that I have, let's see, do I have it through the sides? Yes. So the vents on the sides, that didn't work the way I wanted to. Okay. Yeah, so the vents on the sides have these kind of shields over them, so they'll only allow airflow downward. And if it is raining upwards, I have other problems than worrying about this box.
Marcel asks when you're adding the Kraken at that site.
When he buys a new one.
What's it called?
Kraken RF is a company, and the thing that Marcel is asking about is a device that has 5 SDRs that have phase coherence with each other, so they run off the same clock. They have an antenna each that you set up in a circle, usually some multiple of the wavelength of the signal that you are looking for, and it looks at the phase difference between each of those receivers for any signal received, and that way you can tell what direction the signal is coming from. So it's a direction finder that doesn't depend on things like kind of the old some of the old T-Hunt systems used a set of like 4 antennas, and then they would switch between them really fast, and so you would end up with a what was it, like a 1 kilohertz change rate, and you would listen for the Doppler changes of the FM signal as your receiver rotated through those antennas, but it required the transmitter to be FM. Using the phase differences, it doesn't matter what the signal is, you'll be able to figure out where it is coming from. And then if you set up a network of these, then you can basically triangulate any signal anywhere.
Is this, will this prevent you from having to do the 22-degree offset related to that?
No, this is, so the Kraken RF makes the direction finder thing, and then they make the dish, but they're separate products. That one is just the polarization of the signal coming off the satellite. In order to minimize loss, I want to match the skew of it as it's hitting my dish. So
How did you get the 22-degree number?
there are a bunch of satellite finder websites and apps on your phone. Basically, just say I'm here and I want to talk or want to receive this satellite. It tells you what bearing, what elevation, and what the skew is.
And just remember the heatsink. Why does the heatsink need antennas?
It's the other way around. So it's the computer in there that needs the heatsink. The computer that is operating the SDRs that are hooked up to the antennas.
Oh, I see. But, okay, you could use okay.
Yeah, so for this particular thing, since it's a sealed box, there's no air exchange with the outside environment, and so it would just heat up and heat up. Air is not a great conductor of heat, so using air to conduct heat from a hot processor to a different heat sink that is then trying to conduct that heat away to air, it's just going to get really hot in there and not be as effective as if I couple it directly to the case. Yes.
What feed are you using for the GOES satellite?
Which one is it? There's one that's made for satellites. The L-band weather satellite.
$100.
Yeah. Well, that's just the feed. The dish is $120 and
Uh-huh.
the feed is $110.
Yeah.
Like I said, don't ask me how much all this stuff costs.
I mean, what's special about this feed?
It's filtered and has 2 LNAs in series. Basically, it's really good.
Yeah, because we've tried the GOES ourselves. It's just that our feed has historically been really, really bad, even though we have a specialized LNA for GOES.
Yeah. If you want to stick with so you have one of the grid antennas.
Yep.
What frequency is the feed made for? Is it a 2.4 gig, 1.9, or 1.7 gig?
We tried making one for 2.4.
Oh, we made one for
Oh no, yeah, we made one for 1.9.
But so we tried the 2.41 originally, and it didn't work at all.
Yeah.
1.9 will work, 1.7 would be better, but it's hard to find the 1.7 gig feeds. What you can also do is to get another grid antenna and mount that grid to the back of your existing grid so it makes it even bigger. And then also something you can do is the little metal thing in front, flip it around.
Flip around, yeah. I've tried that, but
We made a custom feed for like 1.7-ish gig, and it
yeah.
Yeah.
I mean, it was just a dipole.
yeah.
I tried making one and I could not get the damn thing to tune right. I threw it on my I have a spectrum analyzer with a tracking generator and just could not get the thing to resonate at 1.7 gig.
What is the L band versus S band?
There are names for basically UHF and microwave frequencies. Where are they? Yeah, so L band is 1 to 2 gigahertz, S band is 2 to 4, C band 4 to 8, X, KU, K, KA, etc. It's just sort of a way of classifying a chunk of spectrum in a really shorthand way. I think it started with the military because that's the sort of thing they do. Let's see. There's stuff in the chat. Yeah.
The like hacker, like I guess we were talking about earlier. What did they do? What is the I guess your purpose for connecting?
The hacker camp?
Yeah.
Tour camp is, so picture what you would get if you took a small scale Burning Man populated entirely by hackers and nerds. And you end up with a bunch of technology based, sometimes art, sometimes just for shits and giggles installations, like ShadyTel, which is the phone company that sets up the phone network across the island when we're doing camp. There's a group called Bureaucracy, which is effectively a social experiment to see to what lengths people will go to get free beer by making them fill out endless, useless, pointless forms. And, yeah, it's basically just we go, we do stupid stuff, we have fun. And I thought, what would be more fun than setting up a paging transmitter connected to the phone network so that people can pretend it's 1997 again, when pagers were the thing.
So it's like an event you guys have on an island once, or is it that you guys own the island?
Oh God, no. It's put on, the group that puts it on also runs a security conference in San Diego, and then the camp is every 2 years. It's up on Orcas Island in Washington State.
You just like, can anyone just like get a ticket and go, or is it like
Yeah.
What are you talking about?
Ooh.
Oh, damn.
Yeah. So the first couple tiers have sold out. It is a lot of fun though.
And what is that?
That's the hacker camp.
How much code do you guys use?
For this thing,
Yeah.
basically none, just configuring in a couple scripts.
Could you like, did you have to automate anything?
just as far as setting up some system defiles to get things to launch properly on startup. That's about it.
L-band, S-band, and C-band are all like different frequencies, but is there like any specific like reasonings as to like which one would be for different purposes and stuff?
Just different birds that you're listening to, different satellites. They're transmitting different things. So they've got an L-band and S-band, and then they have also one for hydrogen line radio astronomy. If you're interested in pointing something at the sky and figuring out where all of the atomic hydrogen is floating around. You have a question?
Yeah, if you had to like quickly troubleshoot something in a system, do you have remote access or how do you do that?
Yep. So I can SSH in through Tailscale to the computer that's there. I've also got remote access through the router that's at my parents' house to bounce through that. And if those fail, I ask my dad to go and flip the power switch.
Let's say you were to do like multi-purpose receive, a bunch of STRs connected to a single antenna. What would you say would be the best sort of wideband all-rounder antenna?
A disco. The one that I have, it covers like 100 meg to 1.2 gig, and you can get larger ones that cover like 25 megahertz to 1.8 or 2.4 or something. The gain is not great, but it's super broadband. If you do want a very wideband, high gain directional antenna, look at the log periodic. Those are nifty.
Do you think one of those would work as a feed for a Go's dish?
You have to be careful with where you put it in the focus point of the dish, just based on the frequency that you're targeting. I would, if you can get your dish pointed really accurately and you know it's pointed at something you're trying to read, and then you can adjust the position of the log periodic on your feed to get the optimal signal out, I think that would work well. I don't know, you guys have an anechoic chamber here? There you go. Put it in with just a carrier on 1.6 whatever gigahertz and try messing around with it.
Why did you choose each of the 3 antennas that you have?
Let's see, which of the antennas? So actually, I have more than 3. Or are you talking about on the little thing?
No, on the other setup.
Okay. So I've got. No, that's all. All right. So that's a discone for the VHF and UHF stuff, just because it's wideband and was easy to put up. This one is a dual band 1090 and 978 antenna, so I can get both ADS-B and UAT stuff off of it. The HF loop, it just seemed like it was going to be easier to set up than a long wire or a fan dipole or something like that, especially because it was just doing receive only. The antenna, well, I replaced the grid with the Discovery dish because it was going to be easier to get it pointed properly. Okay.
So that's still what that costs, like $110.
The replacement for this is, yeah.
What if we shoot the entire thing?
Don't ask, please. I don't know, and I am not going to calculate that. Too much.
So why are there 3 different ones?
3 different.
And which settings?
Cause they cover different bands.
Oh, it's for different bands, that's.
So the disc cone technically would probably cover 1090 and 978, but I didn't have enough ports on the multi-coupler, so figured I should get a separate antenna for that.
Is there not like on a computer you have like a USB that goes to the type of USB? Is there not anything like that for this purpose?
For dividing the signal,
Yeah.
the multi-coupler. The ones that I had were one in, antenna comes in and then you have 4 ports out. And I had more than, if I had added the ADSB receive to that, I would have had more than 4 things.
Is that dish on the right for Arden?
Yes, it is now pointed the other direction. I tried pointing it to the guy's house in Paso, but there was a tree in the way. But I had clear line of sight to TAS, which is, I don't know, back here somewhere. So,
Would you ever like consider putting like little motors at the bottom so you could control it remotely? Like kind of point it remotely or?
the Arden dish, or
Just like, yeah, or just any.
there's not really a need to.
Okay.
Both the ones that are directional are intended to be pointed at a single fixed thing, and the rest of them are omni.
Well, no, I'm just saying like if you wanted to like pass it, like point it at some guy in Paso's house, or like if you wanted to then like change your line to it or something.
Then I think the conditions under which I would need to do that are rare enough that it just doesn't make sense to motorize it.
So if you're saying that it's like planes in a 100-mile radius.
I can see planes as far as, let's see. So this kind of jagged line is the outlier of how far away I've seen things. So from Templeton all the way to San Jose to just across the Nevada border, down past LA. So that is, for this one, around 175 nautical miles. Which is, oh,
Nanometers.
200 miles, about 270 miles. Wow, all right. There we go. That's how many furlongs. And if you've seen Terminator 2, that's how many of that guy.
Oh, that's funny.
What is wait, if you go back to this screen all the what is it? What is like the jagged, like the big kind of in like and the angle a little bit lower down. Yeah, like what is that?
That's the range at which I have seen
Oh yeah.
the furthest aircraft.
Yeah, sorry, I was asking like why does that occur? Like how come the other one it seems like kind of reasonable, how come that there's just like nothing there?
Combination of geography and flight paths.
Oh.
Yeah, the antenna is only located about, I don't know, 10 feet, 15 feet above ground level. And though it is kind of out in a big open area, it's still subject to there being hills and mountains in the way.
So you're only seeing planes like low Earth planes.
No, I see them up high as well. Anything that's basically anything up. I'm probably not going to receive anything directly overhead just because of the radiation pattern of the antenna. But yeah, I zoom in. I mean, here's a plane nearly directly overhead. And here's one, not too far away that is at 36,000 feet.
say do you not have any polar weather station going on if you have goals going on already, right? I mean, you can pick them up with Omnis anyways, right?
Because I don't think what they produce is as interesting. I don't really care about the WeFax stuff. Also, they are decommissioning most of the polar satellites.
Yep. Noah.
If you had to build a replica of this and position it so you would get maximum coverage, where would you pick? What location would you pick? What would go into the process?
A mountaintop somewhere.
Has,
Just higher you get, the further you can see.
I mean, look, place-wise, or how far from your current station would that have to be?
Oh, I don't think it really matters. If I could put them on all the hilltops, I would.
has anyone tried to like make a portable version of this, like bring it to Mount Whitney or something like that?
I don't know. I know people have made portable ones. You can feed a GPS receiver into this software and it will update your location on this map. You can also run a local map tile server and use that as the map source instead of an online map. So if you are out in the middle of nowhere, you will know where you are and be able to see where, in relation to you, everything else is.
Oh, I see. So you could like hypothetically, I mean, I do a lot of mountaineering and for a very large portion of it, I'm a lot of remote areas. So I could use this to really limit a location of people that are back here.
No, so this is receiving what planes are transmitting. It doesn't do any transmitting of its own.
But, sorry, I could use this to send my location to something like this back here.
No, again, it's not transmitting any location. It's receiving what the aircraft locations are.
Oh, I'm saying that if I had something that could transmit like an aircraft.
Then the FAA would be very frosty.
Okay.
I mean, you can get an APRS transmitter, and that's gonna be the, ham radio equivalent. Just sends a packet on VHF, and you can plug a GPS into it, and it'll beacon your position.
The tiny little portable ones for the small planes.
Is your, if you wanted to transmit yourself, or you have to add to
Transmit ADS-B.
anything?
I'd have to add a transmitter.
Is that,
These are just all SDR receivers only.
is that another antenna?
Yeah, it would have to be. Unless, so I could put a transmit receive switch on one of the antennas there, but then all of my SDRs would not be able to hear anything while I was transmitting. If I had a separate antenna, I would need a lot of separation, probably vertical separation, so that I didn't just blow out the front ends of all of my SDRs. The RTL dongles have basically no selectivity. So if you have a strong signal, that's what you're receiving no matter where you're tuned.
So when you say blow out your SDRs, you mean the safe or the transmitter would control them?
If it was powerful enough, yes, but generally it's just going to overwhelm them so that the only thing you see is the signal that you're transmitting, no matter where your SDR is tuned to, unless you have a lot of very narrow filtering in front of it.
Have you ever thought about doing transmitting messages or something like that? Or adding a transmitter?
I might do something for MeshCore, which is, if you've heard of Meshtastic, MeshCore is what Meshtastic would be if the Meshtastic devs actually paid attention to the learnings of APRS from the 90s.
I don't know what mesh tastic is. I just
It's just an unlicensed kind of flood routed
that doesn't scale well.
No, it does not. Any other questions? Any rants you want to hear about mesh testing?
Yes, please no mesh test.
Cool.
Alright, thank you so much.